Our lesson for today is about the normal distribution. Ano nga ba ang normal distribution? By definition, normal distribution or the Gaussian distribution is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. It is graphically represented by a normal curve. So this is an example of a normal curve. So symmetric siya about the mean. So whatever man na nandito sa kabila is yun din yung nandito sa kabila. So pinapakita niya dito na yung values mas marami ang malapit sa mean than those na mas malayo sa mean. Note that normal curves have the same shape. So ano yung mga criteria niya? Symmetric siya with respect to the middle value. It is single peak. Ibig sabihin unimodal siya. And it is bell-shaped. Any specific normal curve is completely described by giving its mean and standard deviation. So parang sinasabi lang nito na pwedeng magbago yung steepness niya or yung flatness niya depending on these two values. Okay? Your mean and your standard deviation. So alin kaya dyan ang magpapabago ng kanyang steepness or flatness? So we have here our normal curve. Okay, yung mean natin, let's say we have 0 with the standard deviation equal to 1. So anong mangyayari kung i-change natin yung value ng mean? As you can observe, changing the value of mean moves our normal curve horizontally. How about kapag i-change naman natin yung standard deviation? So kung ilalapit natin yung standard deviation sa mean, nagiging steep yung ating normal curve. At pag pinapalayo naman natin siya, mas nagiging flat yung ating normal curve. As observed dun sa example, the mean is located at the center of the normal curve. In fact, hindi lang yung mean. Even the median and the mode, magkakasama sila and they are all equal. Lahat sila nasa center of the normal curve. Changing the mean without changing the standard deviation moves the normal curve along the horizontal axis. Diba nakita natin kanina, kapag change natin yung mean, lumilipat siya ng pwesto horizontally. Okay? And changing the standard deviation affects how flat or steep the normal curve is. So kapag lesser yung value ng standard deviation, mas nagiging steep siya. At kapag larger yung value ng standard deviation, mas nagiging flat yung ating normal curve. For a normally distributed data, we have this empirical rule, or sometimes we call the 3 sigma rule or 68, 95, 99.7 rule, which states that almost all observed data will fall within 3 standard deviations from the mean. So kapag meron tayong normally distributed data, 99.7% ng data natin within 3 standard deviations siya. Okay? So, very small na lang yung mga greater than 3 standard deviations. Specifically, sinasabi ng empirical rule natin, kaya nga tinawag siyang 3 sigma rule. Okay? Ito, it states that within 1 standard deviation from the mean, approximately 68% na ng data yung nandyan. Okay? Pag nag plus 1 or minus 1 tayo doon sa ating mean. At within 2 standard deviations naman, approximately 95% na ng data values natin ang nandoon. And 3 standard deviations from the mean, 99.7% na ng data values natin yung nandoon. So yung remaining 0.3%, yun na yung more than 3 standard deviations from the mean. Note that yung buong proportion nito is 100%. Okay? So pag sinabi nating area ng normal curve, parang sinasabi natin that is equal to 1. Kasi nga 100% yung ating proportion. Now, let's take a look at this example. The distribution of heights of grade 9 students in a certain school is normal, with mean equal to 150 and standard deviation equal to 3. What proportion of the grade 9 students have a height between 147 centimeters and 153 centimeters? Or what proportion of the students have a height greater than 144 centimeters? Or what proportion of the students have a height greater than 156 centimeters? So, isa-isahin natin. Anong proportion daw ang may height between 147 and 153? Observe that 147 and 153 are one standard deviation from the mean. Kasi 150 minus 3 is 147, 150 plus 3 is 153. Since one standard deviation siya from the mean, then we say that approximately 68% of the data values fall within 147 to 153 centimeters. So, nandyan yung heights. No? 68% ng heights nandyan sa values na yan. 147 to 153. How about the proportion of students with a height greater than 144 centimeters? Looking at our normal curve, okay, observe that ito yung one standard deviation, right? Ito naman yung two standard deviations. Meaning, from 144 up to 156, 95% na yan. Okay? 95% na based on the empirical rule. However, meron pang small portion here. Okay? So, kung 95 yan, ilan na lang yung kulang? Etong portion na to at etong portion na to, that is 5%. Okay? Kasi nga, yung etong part na to, 95. Pero isa lang naman na part yung gusto natin. So, what is that? That is 2.5%. Kalahati ng 5%. So, if we have 95 dito, plus 2.5 dito, ilan ang total niyan? 97.5%. So, 97.5% of the heights are greater than 144 centimeters. And finally, what proportion of students have a height greater than 156? Okay? So, from here, di ba, one standard deviation yan. Ito naman, two standard deviations. So, that is 95%. So, ilan ang naiiwan? 5% lang. Okay? So, parang yung sagot natin sa letter B kanina, since isa lang naman yung hinahanap natin, then this is 2.5%. When we deal with a binomial random variable with large number of trials, you might observe that calculating the probabilities will be too difficult or impossible without the use of statistical tools. If we investigate the shape of a binomial distribution, we can observe that it resembles the normal distribution when the probability of success is approximately 0.5 and the number of trials, yung n natin, is large enough. In fact, the closer p is to 0.5 and the larger n is, the more it resembles the shape of a normal distribution. Tulad ng mga pinapakita kong mga figures dito. We can observe from these figures how the values of p and n affects the shape of the distribution. However, how do we determine if n is already large enough? So, depende yan sa probability of success. This is because when p is close to 0 or 1 and n is small, the normal approximation would yield inaccurate result. Tulad nung nandito sa figure 1 natin, no? Hindi pa siya mukhang normal. Pero kapag pinapalaki natin ng pinapalaki yung n natin, look at the figure 4. Okay? Ina-approximate na niya yung normal distribution.